All right, number 3, I see absolute value inequality. Find the vertex. It's going to be whatever would set the inside of that absolute value equal to 0. So it's going to be the opposite of what it looks like. It's going to be 1. Then outside is going to shift your graph up or down exactly the way you think. So that will be -2. So I'm going to go 1, -2. Now, in terms of any kind of a slope or anything, this just would have a 1 in front of it. So I'm going to go up 1 over 1 on either side of that vertex. This is going to be a dashed or dotted line. It's just strictly greater than. So the boundary line here is not going to be part of my solution. And then greater than goes above. So all the points above your boundary line up in here, that would be solutions to that absolute value inequality. For number 21, we learned that if you have an irrational root, which you have here with your radicals, its conjugate is automatically also a root. So all you have to do here, if this is a minus, you just change it to a plus. If this is a plus, you just change it to a minus. So 2 other roots here, 2 plus the square root of 2 and 4 minus the square root of 5. For number 22, total number of roots that you have in a polynomial just matches the highest power. So this question has 6 roots, or zeros as we would call them. Now, in terms of what are real or imaginary, we don't want to confuse this with the rational root theorem. This is just possible combinations of real or imaginary. Now, imaginary solutions, something like, I'm just going to make something up, this isn't even for this problem. So 2 plus 3i. This has got the same concept as what we just did with irrational roots up here. If this is a root, automatically its conjugate is also a root. So imaginary zeros always come in sets of 2. So I'm just going to do even numbers up to 6. 8 would be too many because we only have a total of 6. Okay, so then the possible real roots have to balance these out to add up to 6. So if we don't have any imaginary roots, we need 6 total. This would have to be 6. If we have 2 imaginary to add up to my 6 total, I'd have 4 real. If we have 4 imaginary, we'd have 2 to add up to my total of 6. And then finally, if I have 6 imaginary, then we would have 0 real solutions. Those are just possible combinations. Those are not the actual solutions to that question. Okay, so for number 23, couple ways to do this. This is a difference of cubes, and so the factored form here, a minus b times a squared plus ab plus b squared. And what I've got going on here, I have x cubed, and 64 is 4 to the 3rd power. So the factored form of this would be x minus 4. Everywhere I see an a, I'm going to replace it with the letter x, and everywhere I see a b, I'm going to replace it with 4. Now a squared would be x squared. A times b is 4 times x. And then b squared here would be 4 squared, which is 16. Now this is all I've got going on here is the factored form of this, and so I can see one of my answers right away would be 4, and then you always have to use the quadratic formula on the other factored form there. So for this one, -4 plus or minus the square root, 4 squared minus 4 times 1 times 16, everybody over 2 times a, which would be 1. This is one answer. I should have a total of 3. Using the quadratic formula will give me the other 2 answers. So one answer is 4. This is -4 plus or minus square root. Simplify this, -48, everybody over 2. Now, whatever you have here, in this case, sum of cubes or difference of cubes, whatever's under this radical is always negative if you've done this correctly. And it's always divisible by 3 in a perfect square. So if you want to break down that radical, this is -16 times 3. The square root of -16 can be removed as 4i. So that's what I'm going to do in my next step. This would be 4i radical 3, everybody over 2. Now, don't touch your radical, and sometimes you can do this, sometimes you can't. It depends on the question. All 3 of these numbers are even, so I can actually reduce this fraction. They're actually each divisible by 2. So the simplified form here, negative 2 plus or minus 2i radical 3, should always have an I in a set of the answers when you have a sum of cubes or a difference of cubes. So I have one answer here in the 4 and the other two answers here in the negative 2 plus or minus 2i radical 3. Okay, 24. I need two numbers that multiply to get me negative 16, same two numbers add to get me negative 15. Now, the difference between factoring a quadratic and factoring a quartic in this format, oops, sorry, this is not an equation, we're just factoring. You just, instead of an x, we're going to use an x squared. That's literally the only difference. X squared times x squared will give you the x to the 4th. Okay, so multiply to get negative 16, add to get negative 15. One should be a minus 16, and one should be a plus 1. Okay, now if we were working with a quadratic, we'd be done. If we're working with a quartic, I just want to check real quick to see if I can factor any further, and you actually can for this question. This is called a difference of squares. This could be factored into x minus 4 times x plus 4. Factors of 16 that add up to 0 because you have no middle term. Now, the other factor here does not factor any farther because of the plus. You're not going to find two numbers that multiply to give you 1 that add up to give you 0 since you have no linear term here. So the only time you really have to worry about this, if this is a minus and this is a perfect square, it can be factored further. If it's a plus, you're just done. So this is what we would call the completely factored form. Okay, some more factoring. This is just a quadratic. Multiply AC, add to B. I'm going to use the Berry method here. A times C would be 9 times negative 2. So factors of negative 18 that add up to negative 17. Now, the Berry method has you just take the first term and drop the squared. This is not going to be the answer because 9x times 9x is not 9x squared, it's 81x squared. So one of these is going to be manipulated here a little bit. The two numbers that fit both of these categories, this would be negative 18 times 1 and negative 18 plus 1. So for one of these one of these factors, just put a minus 18. For one of them, put a plus 1. It doesn't matter the order that you put them in. Okay, now one or both, in this case it's just one of the factors, will have something that is a greatest common factor between the two terms, and that's going to be how we get our real factor. These two numbers are both divisible by 9. This does not come out in front. It literally just disappears. And so the real factor here should have been x minus 2. Now, 9x and 1 don't have anything in common, so that is the real factor, and this is the factored form. Easy to check. You could FOIL this back out. X times 9x is 9x squared. I usually just check at least the first term and the last term. If I do negative 2 times 1, that gives me the negative 2. So I should be in good shape. Now, different from this question, you don't see an equal sign here. This question has an equal sign. Okay, so what I'm going to do anytime I have a quadratic is set this equal to 0. So I'm just going to move the 30 real quick over to this side. Now, this is totally your choice. There's lots of different methods we talked about. You can factor this, and you can always use the quadratic formula. You can always use completing the square, but I think that would be difficult for this question. You can't solve using square roots here because you have an x squared and an x. I would say if this was me, two numbers that multiply to give me 30, that add to give me negative 11, I can think of those pretty quickly off the top of my head. X minus 5 and x minus 6. Multiplies to give me that positive 30, adds to give me the negative 11. So I would factor this. You could also use the quadratic formula. Now my actual answers are whatever I would plug in here to set this equal to 0. Now, you don't have to set up, I would add 5 here, an equation, and I would add 6 here. If you can just recognize that, hey, I'd plug in 5, that would be 0, hey, I'd plug in 6, you don't have to write that equation out, but that's what you're doing is you're trying to determine what would set the parenthesis equal to 0. If you're multiplying two things together and they equal 0, if this was 0, it would wipe the whole thing out. or if this was 0, also would do the same to make that equation true. Okay. Probably should have some arrows on this lovely graph. The domain of any quadratic function is always the same. Domain is how you move left and right. I would always encourage you to approach from the left. This goes to the left. I know I'm off the screen here. This will eventually go over to the left forever, to the right forever. You're going to cover the entire x-axis here. So this is negative infinity to infinity, or in interval notation, sometimes known as the all real numbers. Or the same as all real numbers, if you will. Okay, now for your range. Range is your possible y values, so how you're going to move up and down. Always approach from the bottom. So I don't start touching any part of the graph until I get to the vertex. Your range is your y values. This is the 0.22, so maybe this isn't the greatest example, but I'm using the y coordinate here. Now this is going to be a hard bracket because I actually touched this point, so my lowest y value is 2, and then this goes up forever, so the rest of the graph will go to infinity. You never have a hard bracket on infinity. Number 28, factor completely. First thing I would look for, does this have a greatest common factor? And I would tell you all of these numbers are divisible by 4, and all of these numbers are divisible by at least an x. So I'm just going to divide each term, and I'm going to pull that out in front. This would become x squared. 16 divided by 4 is 4, and I'm taking one of those x's out. Negative 128 divided by 4 is negative 32, and then that x is totally removed. Now, what's in here, multiply to get negative 32, add to get 4, can be factored down a little bit farther. So there's only two numbers that fit both of those requirements. This is going to be negative 4 times 8 and negative 4 plus 8. So those two requirements are met, minus 4 plus 8. No answers here. This is not an equation. It just says factor completely. Now, this is factoring out a GCF, greatest common factor. We'd be looking for this on the answer key because it says completely, and this quadratic can be factored into those parts further. Okay, 29, solve. Again, you can use quadratic formula on any quadratic equation. I'm going to go ahead and factor this because I know that I can. This is going to be multiply, so factors of what I'm going to multiply together, a times c. 4 times negative 15 is negative 60, and I want to add to get negative 7. Now I'm going to use this Berry method that I used at the top of the page, but on that question we didn't have an equation, we were just factoring. Two numbers that multiply to get negative 60 and add to get 7, negative 12 times 5, negative 12 plus 5. So one of these is a minus 12, one is a plus 5. Now the Berry method has that little trick to it, 4x times 4x and not 4x squared. So one or both of these is not the real factor. What you're looking for is like what I have here. These are both divisible by 4, so that's not the real factor. The real factor there is x minus 3. 4x and 5 don't have anything in common, so that is the real factor. And just a little spot check, x times 4x, 4x squared. Negative 3 times 5 is negative 15, so I know I'm in good shape. Now, I actually want answers to this question. So if we did x minus 3 equals 0, x would be 3. For this one, 4x plus 5, what I would do here, we would subtract 5 and divide by 4. So the answer there is actually a fraction, negative 5 over 4. You'd get the same answers if you did the quadratic formula. Okay, one more question on this page. For number 30, I would break out, let me pull this to the side, I got a glare. Alright, break out your graphing calculator. Alright, now, if you haven't already, I would change my window to be something normal, like negative 10 to 10 and negative 10 to 10, just for a starting point. And I'm going to go ahead and type this polynomial. So x cubed minus 3x squared minus 4x plus 12. Go ahead, hit my graph button, see what we got going on. Okie dokie. Now, I can see where the graph crosses the x-axis pretty clearly on this window. It looks like -2, +2, and 3. If you want to verify that just real quick, I'm going to hit second graph, which the function is a table. And I'm just going to check these numbers. Okay, at -2, just confirming my y-coordinate is 0. At 2, my y-coordinate is 0. And at 3, my y-coordinate is 0. So here was my graph. Okay, we're going to translate these real quick into linear factors. If that's your 0, x plus 2 is my linear factor. If this is my 0, then x minus 2 would be the linear factor. And if 3 is my 0, x minus 3. So these are all linear factors of this quadratic. This says which of the following is not. Okay, so we said x minus 3 is, x minus 2 is, x plus 2 is. So the only one, the graph did not go through -3. So this is the linear factor that would correspond to a 0 of -3, which if you want to look back at the graph, here's -3, I'm nowhere near 0. So that's going to be the not the linear factor.